It's gonna go to the cloud. All right. All right, we are at the official first 2023 Distributed Systems Reading Group, discussion group. I am now officially the kind of main host of this, giving Brooke more time to do Brooke things. And we have other fellow visionaries around here with James and Brian and Philip. So if I falter in any case, I have good friends around. And so, yeah, this is our first paper. We'll get into this in a second. I think for people who are maybe new to the group, obviously we ran this, I think, for the first time last year, which I've linked on multiple things within the Luma and elsewhere, all the previous recordings and chat transcripts and everything that are available. So you can go back through those. A lot of last year was an interesting mix of covering kind of foundational distributed system papers among some other more interesting ones around CRDT, data log, and some other ideas. This year, I've only scheduled, we're going to have one every month, but I've scheduled just the first three. So let's see what people start getting more thoughts on some interesting papers and ideas. We already have ones for February and March. So, those are ready to read. Personally, for these kind of group things, I have to read them literally like the day before, or I'll forget if I try to read early, unless it was really, really good or I needed it for something. So yeah, that's kind of the intro. Hopefully, we can do some interesting stuff and people have more ideas or themes or things that they want to kind of go into. And I hope to try to have a good combination of, again, more recent research and then older stuff. And already in the first 3 months, we have, this paper is new. The next paper is actually from 1990 about distributed reset. And then we have some stuff moving toward multi-tiered computing, which is something I did a lot of looking at. And I was realizing, there's a bunch of new papers that I saw from some university reading groups. That's back to some new stuff. So we're kind of going new and old and new and old. So everybody doing well? Everyone having a good time? 23 so far, so good?
Yeah, we just announced our company this week, 2 days ago, at the Chiplet Summit, which is all about distributed system stuff. The paper that you should all be interested in is there's a brand new paper published by Basil Al-Khatib, who is in Samir Al-Kishwani's group at the University of Waterloo. It's called Partial Network Partitioning. It will probably be the important paper that's published this year. And I'm hoping that we're going to cover that paper in a future session of this distributed systems reading group.
Cool. I will look at partial network partitioning. Okay, cool. That sounds really up the alley. Cool. Thank you, Paul, for that. And we have for people who want to add papers, we have the Discord channel. We have a discourse forum for that. So please add stuff and we'll go through it. All right. So for this paper, we always, I think we'll continue this tradition from last year. Does somebody want to give kind of a kind of intro of the paper that we read on Reflections on Trusting Distributed Trust? It has a very linking title to a very famous paper, but we can talk about that. So anybody want to kind of give it a go? Voluntarily. No one. You're gonna leave it to me. Is that what you're saying? Sure. Nobody wanted to give it like a quick intro? How many people read this paper? You do that. Oh wait, I got a hand. Listen, you want to give it a go? Is that what that means?
Yeah, sure. I can.
All right. I like that. So I'll have a lot more to say on this paper as well too. Cool. Go for it.
All right. So sort of gist of it is to have a distributed trust. According to the design, you depend on various trust domains, and you basically bet on a number of them, all giving you all executing same code and giving you the same values. And what they propose here is that one, you have to use trusted execution environment, which is always the case. But to have developers, application developers, or to make it simple for application developers, you use one trust domain, which is like the application developer itself, maybe running a local machine, running on a local machine, and then using various other trust domains, and all of them running, a secure hardware. And the way they sort of design it is in that all these secure hardwares, they have append-only log, which would keep track of what programs the secure hardware runs, and also can give a hash of the current program that's running on it. So whenever a client wants to know what what program is running, or wants to verify what program is running on the server, it's readily available for them. And they also propose a way to say do the deployment, where they introduce a sort of framework in which the application runs. So that is to enable updates, as in when the application developer wants to deploy it, the program in itself will be deployed into a execution framework in the secure hardware, and the program is then sealed within, and the hash is provided for anyone for verification. And also the code as well as the framework are supposed to be open source to increase trust in them. And further they sort of put in some suggestions as in how to do updates. So that's again like only to have the application developer do updates, use a public key where for each update you have to provide a private key and verify against the public key, and also to always run the new updates in a sort of sandbox environment to make sure it's not sending out a false update or false hash to its clients. That's sort of what I got from it. Mostly the gist of it. Yeah.
Cool. Thank you. That's actually really good. You hit on a lot of the right points, and I think so. Maybe we can cover this in a couple of ways. And for people who maybe even skimmed it, would be good is I think this section. Obviously, we'll talk about auditability versus like verification. I think that's obviously a big choice that they made here. There's this section on 2. I think is a really great kind of view on all the different kinds of applications where distributed trust is really key. I worked previously at a place that was obviously around blockchain and wallets and things like this, and financial custody in this digital space is a major issue. And so that comes into play along with some of the other stuff around privacy, and that's obviously a big part of we think about a fission too. But I want to get a sense from like in the motivations. One of the notes I have here is that they talk about that most applications today go with the assumption of non-colluding servers, which, having worked in a lot of places, there's a lot of people I've worked with who were like, yeah, we run in Amazon. We just trust the network in Amazon. Don't worry about it. Which, you never know, right? We've seen bad things happen. So maybe people can talk a little bit about from the motivation of the space. And this is a workshop paper, right? So it's really trying to motivate. The key thing here is trying to motivate. It's and I think the 2 big motivations are obviously around the audit log, around easy deployment, and around really leveraging secure hardware in a heterogeneous way. Does anybody want to talk about like, do the motivations of this paper, are they important, or is this kind of like hitting from a field where that's too obvious? Might be a really good question. So I leave it up to people to kind of talk about like from a motivation and goals of this paper, what do people think? Is there too much trust in secure hardware, for example, here?
There has been a lot of concern about how much can we trust secure hardware, how much can we trust hardware not to inject flaws or viruses, how much do we trust, do we trust the foundries given international spying issues? I remember Knuth asking about trusting the C computer not to inject, the C compiler not to inject something. It's the same problem, right? I'll be honest, I also haven't read the paper. But what I was reminded during the description was, oh yeah, this is also the problem Holochain tries to be solving with checksums on the executables and guaranteeing that it's a perfectly valid concern for obvious geopolitical reasons in a global supply chain.
So just to give you a quick heads up here, I was at Apple in their infrastructure team and had a great deal of insight into how supply chain management was an issue for security. I can't tell you anything about it because I was under NDA, but this is obviously an issue these days, and I think this paper touches on exactly the right kind of problems. Just so you know, the last 3 days in San Jose, this conference on chiplet, we call this Chiplet Summit, almost half of the papers and the discussions were about how do you manage the supply chain and how do you deal with the security issues in there. Do you, for example, use puffs, physically unclonable functions? That's something you should be in your vocabulary now.
Yeah, that's actually a great point, Paul, and Mark bringing it up. Yeah, I mean, I think this is the like oncoming thing. I mean, I remember even having done a lot of stuff in some of the networking space, and there was a lot of workarounds. Obviously, all the SGX stuff out of Intel, and I remember we had for Papers We Love in New York when I was still there. I think we had, I think Jessie Frizzell was going to present one of the SGX papers. And like the day of her presentation, there was like either a post or another paper that exploited all the SGX and some of the issues that they found, right? This is like an ongoing changing environment. I mean, they talk about some of the privacy DNS examples there, and it's how hard it's been to actually get stuff off the ground, which is obviously a big part of this paper, moving toward this kind of audit trail and client user auditing. So I think, to that point, yeah, I mean, secure hardware, we're going through a lot of that. And obviously, I did a lot of stuff at Comcast in the networking space, and we looked at a lot of this kind of stuff as well. And obviously, a lot of the pain points that are there. So yeah, it's pretty interesting, I think, where things are going on this front, and how much trust we're giving to secure enclaves or trusted execution in general. Has anyone else kind of worked in this domain of hardware security modules, this kind of thing at all? Other than Paul, I guess. But or Paul can talk more about it. I would love to hear, because there was especially with the SDX stuff more, how we can leverage hardware, but also how we control what software runs where. But there's obviously a lot of, obviously one thing when you think about moving things toward these enclaves, you're paying a bigger price, or you're moving back to trusting some of the bigger companies like Apple and others who can actually invest in the space. How does that work for developers who can't do that or can't afford that, and have to do more in software, right? That's great. Brian?
I think part of their full idea, though, was that was to try to approach it in a trustless way, right? And so I wonder what folks think about, their sort of approach really requires that the code that's running in the enclaves is open source, or at least public, so do folks think that's realistic?
There's a very interesting problem here, and that is, I don't want to disturb the flow of the meeting, but but I'm deep in this stuff right now, and I have been for at least 5 years. And one of the things that we do is we talk about Byzantine fault tolerance. And the reason for that is because you can have evil things happen to you, even though someone didn't intend to. So it's really important to recognize that, deliberate, intentional attacks are just one hazard that you have to deal with. And sometimes they're indistinguishable from unintentional hazards that people inject in the system. So that's why it's important to have teams like this, and the Zihan is leading here, actually explore all the space and discuss these topics.
Yeah, 100%, right? And I think obviously the big one here, again, having looked in the space personally, this 4.2 section, right? Deployment tomorrow. This is like a hard, so the paper this has a lineage and title to, right? I think that maybe you're referring to this one. Mark Antoine it's the Ken Thompson paper, right? Reflections on Trusting Trust, which is one of my favorites going back for forever. If anybody's ever read that, somebody can link that. I'll make sure I do it afterward as well. Which was about trusting the compilation, and like, what if the thing you compiled and when you ran it on the compiler, like issues occurred. They're like, it's essentially this like super inception like world that we can live in, right? And having a lot of friends who look at things in programming language land and compiler land, like CompCert, where like, oh yeah, sure, you might have your binary that you compiled is safe and secure, and doesn't treat host memory really horribly. But how do we know the thing you compiled it with, which you trusted and maybe it's been around for 30 years, is correct, right? And obviously, I think as we move into distributed trust, I mean, this is more and more. This is much more of like a really open space, and like it's cool. Like AWS is offering Nitro, Intel's SDX, which other providers are also giving. So people have been thinking about it and paying for it. But it's funny because when I think of, this is probably the closest paper to think about like the open view on this, right? Like for anybody, to Brian's point, where when I've always thought about the space, it's like, Apple, it was like only people who run these things really care about this, right? Like how do more people care about this, right? So I think that's really key, because they talk about bootstrapping heavily here, right? And that's really tough. And that's, obviously I think to be the biggest like idea really coming in, like, can anybody kind of do this even for small kind of trusted flows for compute or computation, whatever the case might be. Anyone else kind of pick up on some of these things in terms of like, what do we think about, is this enough in terms of like having this audit log, having these building blocks? And I want to talk about that before we maybe look at their like prototype evaluation. So any thoughts there from anyone?
I was going to point out that on the previous page, there are some non-goals, which essentially are things that this doesn't do, but are important, like verifying that the code that you're actually pushing is what you expect. And for example, when it's compiled, that you're not getting changes to it. So I just wanted to point that out for people, that they do mention there are aspects of this where it doesn't cover everything. So we would definitely need to approach those as well when we're doing this.
Right. Of course, I think the one thing they hit on with backdoors is like the application developer who, upon deployment, who will kind of take themselves out of, or just be one participant of a larger system. Of course, when they wrote that code, they could have put in a backdoor, right, which would cause everybody running to make an issue, which I think is, these are interesting. Those are kind of interesting things, right? So the non-goals are really good. And of course, like, I think it's kind of in this paper, and I don't know if this is something to kind of bring up for the larger group. And obviously, I'm somebody who works between, doing more academically minded work around, less around security, but like, I do like obviously this divide of like type systems and people who work in like dependent types versus the languages we think about today. And all these things. Obviously, from this case, it's where do we look at verification versus something which I think this paper puts forth as something much more practical, minus some of the open source things you mentioned, Brian, of course. But I think there's a lot here of like, a lot of people have been trying to say like, hey, before I run something, can I verify, can I guarantee these things versus this kind of ongoing, again, auditability. Where do people see? I mean, like, should we focus much more on verification, or are these kind of worldviews that this paper is showcasing really the direction we should go more practically, or where do people think the divide lies there?
I can give
Paul,
some
please.
insight on this. So the biggest hazard that I've seen in large infrastructures, and I think this is true also at Amazon and at Apple, at Microsoft, is that you can have a perfect system that's properly audited. It's got a tool chain that's verified, and it's putting the right code in the system. But then the attackers come in through the network, and they basically use a zero-day attack to get from the application into the kernel. This happens a lot. And then what happens is once it's in the kernel, it buries itself, hides its logs or erases its logs, the logs that saw it there, and then it can sit there for hours, days, weeks, months, sometimes years. And when some event happens, maybe it's a timestamp, maybe it's an arriving packet or whatever else, and it wakes up. And when it wakes up, it takes over the network interface controller. It basically puts it in promiscuous mode. It listens to all the traffic coming through, and then it can hear any authentications that's happening that's in the clear, and that happens a lot. Unfortunately, behind a firewall, people assume that they're safe, and they're just not. And then what happens? It just sends a few, poison packets to the switch, which basically exhausts the tables in the switch, and then all of a sudden the switch starts to sing. And then it can hear everyone's packets. And then it's basically got access to everything in that local network. So the problem is not that, is the tool chain getting this executable into a system correctly, and are you able to audit it? The problem is that the existing systems, particularly the way that networks work, the any-to-any addressing system in both Ethernet as well as IP, it causes this problem of other things being able to hear the packets and these vulnerabilities that are intrinsic in the way that networks work. So that's the bigger issue in my mind.
Yeah, that's actually a great point. And obviously there's like a whole space. I mean, we haven't really covered this in this group. I actually highlighted a person here, Arjun Panda, who is now at NYU and was a big influence on work I had done previously at Comcast, where we were doing work around network functions and verified network functions and stuff like that we run. But when I was doing a lot of this networking stuff, to Paul's point, I mean, the network, there is a whole set of research on trying to verify things. I mean, between bad configurations, bad hardware, just the topologies that we have, issues with BGP. I mean, there's only things that come up in the space just within the network themselves. There's a whole line of research trying to do that better. And it's very slow, right? Actually coming into practice, at least working at an ISP like Comcast in the United States, like those new ideas were just not coming that fast to core networking. And I can imagine that's pretty much the case in a lot of other places. Yeah, that's a good point, Eleanor, as well. So does anyone else want to kind of talk about that? Like, where do they see these larger problems lie? Again, where I think this is like really fits in the workshop paper cases, I think to Paul's point, like there are just so many. I mean, there's no way to kind of fix this. I mean, we still haven't fixed Ken Thompson's original kind of view on reflections on the compilation. So how are we going to do this with the network and distributed computing? So anybody want to talk about that a little further before we look? There's obviously some interesting issues that come to play with these trusted execution environments running things dynamically and performance, right? Which I think is a big reason why this stuff also takes a backseat a lot. But anyone else want to talk before we talk about evaluation?
Well, since that original paper about the compiler security issue, we've realized that there are many, many more issues with the compilers. Even with C, there are so many things in libc and other aspects of the way that the language compiles that this is why we've had to invent languages like Rust, because we need to basically prevent programmers from doing things that they don't know are bad. And another very big discussion going on right now is with another language which is even more strict and but easier to understand perhaps, is Zig. I don't know if anyone's familiar with Zig. It's worth taking a look at. There's some good,
yeah, for sure.
There's some good tutorials on YouTube. But this is really an ongoing discussion about the whole compiler and what it's doing to you. It's not just malicious things; it's things that you don't know you're doing to yourself sometimes.
Yeah, that's right. Yeah, things that you definitely don't know that's happening. Yeah, obviously there's a really good space to your point on exploration of languages like Zig and Rust. Obviously, even things like Rust to allow for unsafe functionality, which is obviously, in a lot of environments that work with FFI, you still end up doing a lot of unsafe things. You hope that the developers write abstractions around that unsafe stuff so that you don't have to work. You hope that things are correct. I mean, but this is an interesting thing because there's people like Derek Dreyer. This is much more in the programming language world, but they're looking at Rust, his group in Zurich. Not Zurich, what school is that? I forget what school in Germany it is. But Dreyer's group is looking at how can they reason about unsafe Rust. How can they reason about unsafe properties of Rust still semantically being being sound with the safe stuff? Because obviously people are not going to not stop writing unsafe code in Rust and things like that. Obviously in this paper, there is the use of WASM here, right? Which obviously comes with some really good properties about sandboxing and stuff, but also brings about interesting things because you arbitrarily running WASM modules as this prototype shows. And then maybe we can talk about it. Obviously, when you get to performance here, we see here what's the increase with adding the sandboxing and press environment execution. What the addition here that obviously they're doing, they're creating this kind of environment to run things dynamically as they get arbitrary code. And they talk about this issue obviously in running it with Node.js, where they get this kind of huge kind of performance drop. Having worked in a lot of places where good or bad product or engineering or not, where everything seems to be performance matters. How much where is the trade-off with performance and security? I mean, it's really, I think, a little bit of what this paper kind of hints at. And when, obviously we want fully homomorphic encryption. We want all the things to be secure and fast. But how do we draw the line? Or when do we draw the line? Any thoughts there?
I don't think we can draw the line. I think it's kind of like a Gödelian problem that is going to be constantly unfolding, and therefore there's going to be this warfare between the people who are trying to get into the systems and the people who are trying to protect. There are some big things that we can do in terms of shifting our intellectual vantage point on how to deal with this. One of the issues is that networks are managed by ACLs, and you go into a router and you're trying to figure out how to manage, sometimes hundreds of thousands of ACLs. This is what happens in a modern data center. I think that's the wrong perspective entirely. What attackers do is they understand graphs. So basically they go in and understand what's going on through their telemetry to the outside. They go in and understand what the graph is, and then they basically attack the graph. So defending that with ACLs is pointless. It's the wrong mindset in my mind.
Yeah, it's actually a great point. And obviously, working at Fission, where you think about decentralization and where ACL, looking more toward capabilities over ACL is obviously a big thing. Anyone else kind of on that at the point? It's a really good one, Paul. Anyone else kind of thoughts there? Yeah, I mean, if anyone wants to say more on that. Yeah, I mean, Mark, yeah, I mean, ACLs kind of come from or ACL, they kind of come from a concept of centralized access lists, like how you work on, that's where I'm kind of going. Though I do think, I mean, to Paul's point on this too, I think a lot of the things that we've kind of been okay with on computing, which I think are things like ACLs. I think of things like how we view configuration over time, and how we kind of treated things in networking that we're used to. I think a lot of the paradigms that we've been used to are the ones that have now actually made it more easy to attack, and it made it really hard for as they explore in this paper in the space of private DNS and not ability to show someone's IP address and query at the same time. These kind of things that I think are really interesting ways we want to go are exactly things we've been so used to that make a distributed trust environment really, really hard, right? It's actually the foundational things that we've been just accustomed to that have been problematic. So anyone else kind of thoughts on here about, I mean, I don't know if people work in some of these spaces that were talked about in this paper, but other than Paul, of course, and maybe a few others, where do you see yourselves kind of coming into play where like this, the idea of bootstrapping and these issues with deployment and, and hardware, as we talked about earlier, where do you see some of that, like actually meshing with what you do day to day? Or maybe not. Maybe we're all cool with the way things are. I don't know. Yeah, go for it. Blaise, right? Blaise.
Yeah, like Pascal. Yeah, no, we're definitely not cool with it. And so the speaking from the perspective of someone who spent a lot of time in traditional enterprise computing and then spent time in cloud computing, and now I guess maybe I'm kind of coming back, it's a package. Defense in depth is a package, and it's a different way of thinking. And I think that anyone who understands that should immediately, at the beginning of any conversation, determine whether or not the other party understands defense in depth. Because if they don't, if they're just thinking about perimeter, then the conversation is going to be difficult going forward. So I'm personally, for what it's worth, I'm kind of done with that conversation. I have not been successful assisting perimeter-based organizations into making a transition. And yeah, I have hypotheses as to why that's the case. But so the good news is that it's now possible to make defense in depth available for free to anybody who needs it. Because we've got Spiffy for authenticating services and applications. We've got Small Step. And I'm just mentioning these names as basically proxies for whatever other open source projects might be adjacent to them. But we can authenticate services, we can authenticate DNS, we can authenticate we have high level abstractions for authorizations with like OPA, for example. And so we can talk about authorization in a way that's independent of the specific implementation. We've got, forward secrecy for a whole bunch of different protocols. We've got Small Step, thank God. I think I have a little candle on my altar for those people that are, that have helped us automate certificate management. all that's accessible. You know, you don't even have to be, you don't have, you know, I do that with no money. I mean, I've been unemployed for months. I'm literally like on public assistance, and I've got a home lab with more security tools than any of the banks that I deal with. That's all.
That's and that's a really interesting point. I mean, you know, having seen the enterprise world as well, I mean, you know, this paper talks a lot about not requiring a lot of cross-organization coordination and human coordination. Where, like, you know, the enterprise, you know, I mean, obviously not related to always trust, but like when there was you know, I remember at certain places I've been, that, you know, it would be like when it was like on call, it's like we gotta get the triage together. There's like 40 people on a call, and you're like, you know, and that still exists, it still happens, right? Like that world's still there. It's sad, and you know, a lot of this, you know, when it comes to like again auditability, you know, trying to find a chain of trust to just with human coordination is just not ever going to work, right? Like, you know, especially as you get into larger and larger institutions, it's like worse and worse and worse and worse, right? So I think that's a really good point, that things have gotten more, you know, component based as well, which has been really good. Paul mentioned a good thing as well. So that's actually a really good point. And obviously, you know, one question that I want to get to at this paper, and maybe you know, Paul's kind of hinted at this already, but maybe people have thoughts, is they offer here some building blocks for kind of bootstrapping these systems, but they also leave this question of, you know, will there be a whole different set of building blocks? Like maybe this approach is maybe trusting, hardware. Secure hardware is not the way. Maybe there's something else, a whole nother world we can go that also won't just be like, 40 humans trying to like make it all work, right? So do people have any thoughts there? Like if just given the term like distributed, trust, how would you go about building, or how would you think that, nothing related to this paper even to that point?
I have a comment kind of towards what Blaise was saying. So I'm in this group just like as a disclaimer here to learn about distributed systems. So I feel like I can't say too much, but I do feel just like systems, like you're talking about a call with 40 people that just seems like really inefficient to me. And it's just like, I mean, like you have just sometimes the best designs are done by either very small group of people or one person. I mean, take Git, for example, version control, just like, and Blaise obviously, has a lot of experience in this, but yeah, it's just like, how do you get a whole bunch of people and pick the right person or a small group of people to design something like this that's going to work? And obviously there's like a whole lot of political, non-technical hurdles to deal with there.
Yeah, that's a great point. And Eleanor raised a great point, right? The extra fiction is killer as well, and the paper provides a way to independently audit, right? I think that's so maybe I think maybe the one thing is whether this evaluation of these building blocks are the exact ones. This idea of like independent auditing, right, might be a thing that we should be more accustomed to maybe. In distributed systems. Yeah, but Mark Antoine's is like, whatever what that means, right? Probably. And so that's kind of a key that I think on this. So to Brian's point earlier, right? Maybe this paper shows it as open source. Maybe it's like some sort of open code within a company or a set of companies, which where this thing kind of will work for auditing all the possibilities for third parties. I do think people will be, companies and stuff who want to move more in this direction will be kind of afraid though to have that kind of openness and transparency. That's also always a problem that people are worried about, right? Even if parts of it are actually these binaries or a black box or something like that. So I can tell you, actually working at Comcast in the networking space, there's been a lot of money made by like people not knowing about what's happening in the network. So, you know, transparency is always an interesting thing there. Anyone else kind of on these, like, what are other building blocks, or what are other, you know, other means you might think about for building out bootstrap systems like this? Is this completely wrong? You know, yeah, Paul, please.
Is anyone familiar with the work that's going on at Oxide Computer?
A little bit. They're doing really nice stuff.
It's really worth looking at what they're doing. One of the challenges with building systems out is basically you buy your computers from a white box supplier, and all of the issues start in the BIOS and the motherboard. And there's a massive amount of old, you know, legacy garbage that's in the BIOS that just is incredibly vulnerable. And so they've taken a fresh look at that and said, how would we build a computer from the ground up, including the BIOS and the firmware and everything else? And I really recommend to everyone, take a look at what Oxide is doing. The CEO of Oxide gave a great talk at Stanford on the E380 series about 3 years ago, I think it was now, or 2 years ago, and yeah, maybe 2 years ago. It's worth looking at. So Oxide Computer.
Yeah, Brian Cantrell. Brian Cantrell, obviously, Sun, Joint, long history on things, and they're doing amazing work. Big fan of their podcast as well. You really want to get into the weeds on, especially on the metal, when they did that in the weeds of a lot of these things and systems and firmware. Really, really good. Blaze, you have another point.
So, so just to one thing that has worked, and this is described, it's alluded to in that book called Accelerate, by the Dora people. It's to change culture. It's sometimes useful to move towards blameless culture. It's sometimes useful to describe phenomena in terms of the metrics and not the organizations or even necessarily a status. So instead of saying that something is up or down, you could say that, like, the latency went from this to that. And so maybe, like, in terms of when you're doing your security audits, you can say, well, we had, you know, there was this much average entropy among passwords, and now there's this much, or there were these many factors in use before, and now there's, you know, these many more. Do you see what I'm saying? So do the comparisons in terms that don't necessarily reflect on any individual person or group. That's like a political thing. The other thing I would say, and those of us in networking take this for granted, but to the point about Oxide is in software-defined networking, there's a concept of control plane and data plane. And I would say anybody going into anything with distributed computing, that's the very first step, is to always understand that there's like the world of, there's the dimension of content, and then there's the dimension of control and all that. So in a sense, what Oxide has done is they've built, the BIOS is now a data plane thing, so it can load and unload stuff, but it doesn't give you visibility into the content of the traffic. It's something the router people came up with. I think that's it.
Yeah, and there's been a lot of work in this kind of control plane, data plane world, software-defined functions, network functions. Research has done really well. There's been a lot of stuff. You have stuff like, obviously, like, between either kernel bypass or things that are working only in the kernel with BPF. I mean, all this stuff is, companies like Cilium as well, who are trying to do the routing, the network layer to work with Kubernetes. And obviously, there was a talk even this kind of supply lines and auditing supply lines and packaging. I think Kelsey Hightower gave a talk at Strange Loop this past year. It's like, all the big companies, the cloud companies, they're looking in this direction. They want to say, and they want to attempt to provide these kinds of things as being a cloud provider. I think that's like in this paper, they talk about where cloud providers need to go further, right? And I do think that's where you're seeing some of the some kind of slow innovation for these kinds of things. There always comes with that risk, right? If we're gonna just go all the way that only these cloud providers can provide these means of security and maybe even some forms of auditing that I use if I deploy to these providers. What does that mean for people who don't want to run compute on, are we going to live in just a cloud world, right? Or we're moving closer and closer to this in a lot of ways. Either you're big enough to run your own data centers, or you run on Amazon, essentially, or maybe if you're doing this kind of stuff. So that's always it's an interesting step, even made by this paper toward its conclusion, but it's also, it's kind of a scary step in its own way, right? Like, so it's a good point. And again, the oxide stuff is actually really, really good. And again, but a certain niche, right? Agos, you had about your hand.
Yeah, thanks. So I don't have very much experience with the topics the paper discussed, but I learned a lot from this discussion and also just from reading it. So one question that I had, or that was a little bit, that I would like to know more about is if you think that there will be more distributed trust deployments in the future, or that there are other technologies that can address the same problem. So my thinking is zero-knowledge cryptography, homomorphic encryption, that will kind of take over maybe of addressing these problems.
Well, the standard criticism of homomorphic encryption is that it's incredibly slow. And that, in theory, you can actually do things. But the reality is it's really slow to actually do any kind of computations. I think there are some other theoretical angles that you can come into security. Most of these are by the category theorists, if you're familiar with that kind of mathematics. I really commend you to kind of like think that way. And that's because you can actually start reasoning about the proofs and the architecture of things in ways without getting bogged down in the details. So there's a lot of work being done here. I think the theorists are actually helping us a lot. And I would imagine that things like homomorphic encryption, someone will figure out how to make it practical. Maybe not this month, but maybe next year or the year after.
Yeah, or maybe the next 10. But
we don't know. That's research, right?
Yeah, and to your point, I mean, that's that line again we talked about earlier, the trade-off of even with some of these hardware secure things, secure enclaves and these kinds of work. That line of how much performance, is necessary, right? If I'm not doing anything in real time, I'm cool to wait longer and longer. But if I care about real time, what does that mean, right? And so, or closer to real time or soft real time. I mean, this is like that line that we keep going back and forth, and where all that kind of research is going. So there is a lot of stuff happening. To Paul's point, I mean, there was even a dream. This is more me coming from the PL side. I mean, a dream when I was first looking at a lot of the dependent type stuff and proof languages like Agda and Coq, but also really like I was really into F-star out of Microsoft, and they had this dream, and they were the first to have the other languages compile out code. The F-star stuff was really cool with actually the OCaml that it could, or the F-sharp, I guess, that it could compile out to was pretty good. And these little demos they showed, and what was a bit, the whole dream of I can write the proof of my code. I can write the proof of my code and also get my code at the same time. And then now I know it's that at least is proven and verified, and it's awesome. I think only Microsoft is still maybe doing that stuff with that stuff, right? So it takes time and a lot of work and a lot of years, and you hope to have one good example that showcases maybe this can be better, right? So I think computing moves seemingly much faster now than it did, I guess. Maybe that's not true. It just seems really fast because I think people are having reading groups like us today, and we're talking about this stuff where maybe before it was just industry and academic researchers.
That reminds me of what I was in the storage industry for a long time, and one of the things that we're trying to manage, for example, is backups and risk. If should you be doing backups, in which case, how often, and how often should you restore them to see if it actually did work? Because most of the time, our customers would actually find that when they tried to do a restore, it didn't actually work. And of course, the last thing you want is when you have a real disaster and you've lost a lot of data to discover that your backups now don't work. The same is true for security. And so I have it's a quip, but it's an important one. We used to say that there's only two kinds of disk drives: those that have failed, and those that have already failed, and those that are gonna. And I think security is very much like that too. It's like, this stuff's gonna hit you. It's gonna get you, and it's gonna burn you. The only question is you can't say when. And so that's why it's important as systems architects to really think ahead and try to anticipate not just individual hazards, but general themes of disasters. Anyway, that's my history.
Yeah. Well, I knew Paul's work because I used to work at Basho and Riak, and like we were just when I was at that place, and the group of engineers I worked with, everything was about where it could fail. We just thought about failure all the time. And that was just the mindset, right? Like there was never a time when things would not would work, I guess. Yeah.
I was very impressed with the Basho and the Riak folks. And I attended the conferences, and in fact, I tried to acquire Basho at Apple, it was.
I remember a lot of this. Yeah.
I was there, and it was my idea, and I actually decided that we probably shouldn't acquire them. I won't go into the details, but as you can imagine from the structure of their ownership, there were some challenges there. But I've never seen such a concentrated group of expertise in distributed systems as at Basho, and I haven't seen it anywhere else. And of course, most of the Basho people have gone off to the Four Winds or whatever now, and some of them went to conferences. Yeah, but it was one of the best conferences and the best groups of understanding about distributed systems that I've ever seen.
Yeah. And it was at a time when research and industry are really tight. We were reading papers, implementing ideas, trying to make people use it, like we did with CRDPs and stuff. So I agree with you. It was really cool. And I think for people who haven't, the conference that Paul's talking about, I think the videos have come back. I think they're like poor resolution, but their videos are back for recon, at least some of them.
Wonderful. I was so sad when I heard that they'd been lost. So the videos are.
Some, not all, but I think at least over like 50% like are around, maybe more actually.
Oh, I'm delighted.
So
that's great.
Yeah. So you can find them if you search Recon. I think they're on YouTube or maybe Vimeo or something like this. And so the videos are out. Like it was a time when we obviously had people who used kind of more typical database company talks, but we used to invite researchers all the time, right? And so that was really a key concept because there was a lot of intertwining there between research and practice. And I think things like distributed trust to kind of end it on this note, when we see a paper like this out of Berkeley, these things are very tied to what people are doing in industry. So this kind of back and forth between research and academic research and industry should obviously needs to be an ongoing thing, right? Like and not just with the big companies. Obviously Google, Apple, and all these companies are doing that a lot more. A lot of you go to NSDI or these big system conferences in academia, you have papers that are now mixed between university people and people from those companies. But obviously we want to see more of that at smaller scales. I think would be really awesome. So cool. I'm gonna stop the recording. I want to say thank you for Paul for a lot of insight. Thank you for everyone else. Next time we have distributed reset, an old but goodie, old paper but a goodie. So thank you all, and then we'll stop the recording now.
So I just put the link in for the paper to the University of Waterloo people on partial network partitioning. So if you want to grab that link, really worth reading, deeply related to all of the things that you guys are talking about.